Hello kids, today I will be discussing what to expect in Physics IGCSE Cambridge course, and this is the introduction to the course. Uh, so what is physics? Physics is a natural science that studies matter, its fundamental constituents, its motion and behavior through space and time, and the related entities of energy and force. Right now, this may seem to be a very vague and very odd description, so I'm just going to give you a shorter version to this. That it's just the science that deals with matter. And what is matter? That everything that we see that occupies space and has some mass is what we call as matter, right? Matter and energy, and how these two things interact. So when we study these two things and their interaction, matter and energy, that is what we call as physics. So for IGCSE 0625 course, we will go through a certain level of content. So let me just bring all the content. This is the complete content that we follow for IGCSE physics, in which it is divided into 6 blocks. The first block is general physics, in which we deal with general ideas about physics. We introduce ourselves to the physics, and we introduce ourselves with the tools that we use to perform all the experimentation that is there in physics, right? So that is general physics, in which we start with measurement. We get to know how to take measurements of several quantities, which are base quantities and derived quantities. And then we study motion, how we can measure motion. We will start measuring motion, and once we understand that, we will go into the background of how a motion is created. So we would apply a certain force, or we will understand the concept of force creating motion, right? And then once we're done with understanding of both motion and force, we will now translate force into rotational motions, a very specific type of motions in which we can get rotations, right? So once we understand that, we will move to momentum, in which we describe motion as a specific quantity in terms of how the mass and the velocity is going to describe the motion of an object. Here in basic motion, we just simply use length and time to describe motion, and in momentum we understand that the effect of mass is also there, right? And once we're done with that, we will move into pressure. And what is pressure? It is just how a force over a certain area is going to be applied, and what is the effect, right? That's what we call as pressure. And once we're done with that, we will understand how energy will interact with mass, right? And that's what we call as basic physics, the interaction of matter and energy, right? So that's where we come to understand energy, and how energy is available in nature, how we can convert one type of energy into another one. So and how energy can be described as power of, or the ability to do work, right? So that's what we're going to understand. And once we're done with that, we will be acquainted with how physics works, and how we can proceed with physics. So this general block is the most critical block in physics. This gives you the brief understanding of how you are going to observe and understand nature around you, and how you can use physical measurements to understand all the motion and the forces around you, and how energy is interacting with matter, right? So that's what physics is all about. So that's why the name goes general physics, right? Okay, once we're done with that, we move into the second block, which is thermal physics. As the name suggests, it has something to do with heat, which again is a form of energy, and how one specific form of energy is going to interact with matter. And that's what we call as the kinetic model of matter, how energy will create kinetic changes or movement in matter particles once we heat them or cool them down, right? What is the effect? And then we will see how different materials behave under special temperatures. So that's what we are going to study in thermal properties, how they conduct heat, how they transfer energy from one place to another, how temperature affects this. So that's what we call as thermal properties. And once we're done with that, we will then try to classify heat transfer, or the energy transfer among matter particles, and then we're going to describe and quantify those effects, right? So that's the last, or the numerical portion of thermal physics. Then we move into the second block, and over here we need to understand we're dealing matter as particle, right? Matter as mass in general physics and in thermal physics. After that, we introduce ourselves to a new way of looking into physics, which is the physics of wave. Now we will start looking at not just matter, but instead the behavior of matter under the effect of energy, right? How matter behaves or moves at a much more smaller level compared to what we're actually accustomed to look at, right? So that's what we call a wave motion. We will introduce ourselves with general waves, right? Waves in the pond, waves of a rope, waves of a musical instrument, the strings, right? How they vibrate. So then we will understand how sound is created, again, since sound is a type of wave. And then we will understand light, which is another type of wave motion, where photons or light particles come from sun to us through wave motion, right? Through vacuum and through our atmosphere. And then we will understand how electromagnetic spectrum is giving us the evidence of how different ranges or different wavelengths of these wave nature of the particles are going to act, and how we can quantify them and how we can utilize them for specific applications. For example, let's talk about radio wave, which is an electromagnetic wave. It is used for long range transmissions, right? And when we talk about light, we get to see optic fibers, which is also a mode of communication. So that's how we transfer energy from one point to another at light speed, and transfer data and information, right? So we're going to discuss how the electromagnetic spectrum enables us. The study of magnetic spectrum gives us the idea of how we can use these type of or several types of these waves for our benefit, right? For daily uses. Then we move into electromagnetism. Now this is actually a very fun topic to begin with, because this is mostly experimental. There's a lot of lab work that can be done on these, just like general physics and thermal physics. Physics of wave is also practical in nature, but for me, I think electromagnetism is the most fun to deal with. So we start with magnetism. We understand how magnetic materials behave and how magnets are formed, and how natural magnets behave, and how prosthetic, or what we say artificial magnets that we create in the lab or industrially, how they're made and how they perform, and how we utilize their behavior for several applications. Then we understand how electricity or charged particles within a material, especially conducting materials, would move around, and how we can utilize that, right? Again, particle movement, energy, as we say, right? And then we move into the effect of electromagnetism, in which we understand how changes in magnetic surroundings or magnetic behavior of one material can produce electricity, and then also how we can use electricity to create magnetic behavior of a metallic object, right, or a conductive object. And later on we will introduce to the advanced topic, which is induction, how one electric conductor is going to create magnetic behavior or electric conduction in another coil or conductor without even having a direct connection to it, right? Through space and time, right? So again, all this time we're simply discussing matter and energy and their interaction, right? We move on to the fifth block, which is the nuclear physics, in which we discuss how the nucleus of an atom, which appears to be just a tiny little, which is usually drawn as a sphere in the middle of an atom, which is positively charged, holds both protons and neutrons, how the activity or the movement inside the nucleus affects the movement of, or the behavior of atoms, again, creating energy or absorbing energy, and that creation of energy is what we call as radioactivity, right? Again, by radio we means electromagnetic emissions by these nuclei, which we call as unstable nuclei. Usually we do not deal with unstable nuclei. They're harmful. They create radiation that is harmful for humans. So these actually materials are handled very safely, and through regulations. So again, this is not something that we cannot experiment with at your level. And then we move into the most unique and the most fun topic, which is space. Right? We get to understand where we live, the solar system that we reside in, the planet that we are on, how it's built, how it came to existence. So it's kind of a history, fun history of how the planetary system came into existence and how these stars form, how the galaxies are there, how we measure large distances in space. So that's what we're going to understand in the block of space, right? Now, for books, I recommend these books. First one is Cambridge Physics, third edition for IGCSE. Again, recommended for IGCSE 065 course code. But I also use Physics Matter, second edition, which is for GCE O level. It is not a textbook directly for IGCSE, but it's a very good read. So if you want to understand topics, I think Physics Matter gives you a much better brief of that. It's more interesting to read. For me, Cambridge Physics third edition was kind of a little boring, but the space block was very amazing in that, which you won't be able to find in Physics Matter perhaps. Not of the similar interest, right? And then I also use Physics Holiday, which is the 23rd edition for reference. It's the master book for physics. It is both used for elementary as well as advanced and college physics. So this is, you can say, kind of a go-to book if you want to understand something, or if you want to explore a unique idea that is coming to your head, and you're not able to find your answers in Cambridge Physics or Physics Matters. Then you can refer to this master book. It will have all the answers that you need, all the fun queries that arise in your head. You can ask your instructor, but I think this book can also provide you fun answers if you know how to read a book using the index. Just look for the terminology you're looking for in the index of the book, and then go to that specific page, read that a paragraph or two, and then you'll be able to understand how physics works, right? So it's an amazing book. Then my most favorite is having a physics dictionary, right? That's the most fun way of exploring, right? I always take out the physics dictionary. I look into some definitions. I'm always revising my own concepts because being a teacher, I have to be up to date, and I have to be thorough. So physics dictionary helps me a lot, and I also recommend this to students to have this the way we have language dictionaries. These science subjects, they also have dictionaries, so have one for the reference. It's amazing. It will help you a lot in recovering from a few concepts. Then for past paper practice, you need to have booklet for paper 2, 4 and 6 if you're going for ATP, right? And that should be at least for last 5 years. If you can get more, then I mean more practice is more rewarding, but at least 5-year papers are recommended, right? Okay, moving on. So how's the exam, which is the Cambridge Assessment International Education, CAIE? It consists of 3 papers with 3 assessment objectives. So in terms of paper, it is divided into 3 sets. Paper 2, which is MCQ, and over here I'm just discussing this only for the extended version. I'm not discussing this for core. The core also has similar pattern, except it has paper 1 and paper 3, which are also MCQ and theory. But for here, we're only discussing this for extended syllabus, which is going to award you at least A star. For core, you cannot go above C grade, right? So if you want to go for A star and beyond, this is what you need to opt for, which is paper 2, paper 4, which is theory, paper 6, which is alternate to practical. In terms of marks, paper 2 has 40 marks, and in terms of the graded weightage, it has 30% weightage for grading. Paper 4, which is theory, that has 80 marks, and it has 50% weightage for your grade. Then paper 6, which is alternate to practical, also has 40 marks, but its weightage is 20%, which is a bit lower than the MCQs, although the marks are the same. So MCQs, I would say, more important. You need to have more accuracy with the MCQs, because that will affect your grade more in terms of final grading, right? In terms of assessment objectives, how these exams are assessed, there are 3 assessment objectives. First is the knowledge and the understanding of all the concepts and the information provided by the book or by the content. I will share the link for the content as well, from where you can download the Cambridge content syllabus, syllabus content. And for Second assessment objective, you have to handle information that is provided in the paper and solve a certain problem. So it's problem solving skill, or you can say higher order thinking, that is required. And AO3, which is experimental skill, that is entirely dealt in an independent way, right? So AO1, understanding and knowledge, holds up to 63% of paper 2 and paper 4 in terms of questioning. And AO2, which is handling information and problem solving, comprises of 37% for paper 2 and paper 4. And mind that both these are inclusive in experimental skills. Mostly you're not supposed to be writing large answers, but the way you have to perform calculations of the given data in ATP, these two skills are also used. The second one, more importantly, is used, but your answering methodologies and everything is entirely separate from these two assessment objectives. Hence we call it experimental skills, right? So that comprises of 100% of the paper 6, which is the ATP, right? Okay, so moving on, what to expect in the course. So what is this course about? This course is at large science that you observe and experience every day. So nothing is difficult or boring about physics, because everything in physics is tangible. And we all do know what is tangible. It's something that can be perceived, that can be felt, that can be understood, that can be done. So that is what we call tangible in physics. So in physics, everything is tangible, even the calculations are, right? So three skills as in terms of personality that you need to develop is to be able to observe and understand. So whatever you have studied in the class, observe those topics in your daily life and comprehend how the science is playing at those processes at the back, right? And then infer whatever concept you have studied in the classroom and apply those to your imagination while looking or observing to a specific phenomenon, right? Let's say a fan in your room. Let's observe how it moves, it's rotating, it takes electricity, and we infer that electricity is a form of energy that makes the fan work. So and eventually we start to experiment with it. We turn off the switch, and we understand that once we cut off the electric energy, the fan stops moving, it slows down, and once we turn it on, it starts moving again. So experimentation will give you the evidence, or what we call as the tangible result, to understand how physics operates. So that's the third most important part in physics, right? Now, keeping in mind that once we're dealing with sciences, where we're understanding the fact that scientific method is to be applied in every possible way in understanding the nature around us. And also, while we're doing so, we need to understand the safety and responsible behavior while carrying out any experiments, right? So for you, let's look at this fruit, right? So this is one way of looking at a fruit, but if you have understood what type of fruit is this, that's fine. If you haven't understood what fruit is this, if you're a bit confused, that's because you've never seen this fruit in this cross section. Perhaps you can say it's a new way of looking at this fruit. By the way, this is just a pear, and over here I could show you some these features. Like in physics, this is what we do, right? We break a problem into several parts. We discuss the basic ideas of how an object is appearing, how it's existing, how it works, how we can break it down, how we can join it together, what we can do with it. We study it in every possible manner. That's what we do in physics, right? Even if we discuss how apples are formed, we need to understand that even if it's a biological process, there is again physics being done at the back by nature that we can explore and study and observe, right? So what's the recipe for A star? You need to understand that you need to understand the third law of motion, which is the infamous Newton's law of motion, that to every action there is an equal and opposite reaction. So you need to understand, you need to let go all of your old habits and move forward into progressive and higher order thinking. For that, you need to gain as much as you can from the lessons, right? Do not skip your school unless it's a severe issue, right? Participate actively in class learning activities, because they will open up your mind towards higher order thinking. Read reference books like novels, understand that you don't need to go through the whole context to memorize that, and to be able to produce good results. You should be able to read them quickly, and that is what we understand as reading those reference books as novels and not just as textbooks, right? And practice your past papers rigorously. You should be able to reflect on yourself and on your performance and how you're doing, track it down, and then see a gradual change. Mark the ideas which you're not able to work with. Cambridge also gives this student booklet which helps you track your performance and how you can improve or plan your improvements. And Lastly, attend assessments and exams which are important, right? So that you can reflect on your performance. So in terms of careers, what are the careers available for physics? Well, actually, I'm an engineer, so physics is a big part of my life. It is said that the engineers can take any job uh, except being medical professionals, and that's fairly true. I don't know anything about fever, how I can cure fever. I just go for a painkiller or something, an aspirin, and just wait for the fever to wear off. But I'm not a medical professional. I cannot deal with that. Even though I've dealt with several types of engineering in my professional career as well as in teaching. But in terms of physicist, well, even physicists can do that. So you need to understand. Even medical science is very adaptive for a physicist. There is no disciplinary boundary for physicists. They can enter any field and they can do wonders, whether it's calculation based, whether it's medical based, whether it's space exploration, drilling, oil rigging. You name the industry and you will find a physicist at the back. Even if you understand statistics or economics, there are also physicists. You would find some physicists sitting at the back at some desk and doing some crazy ideas, right? They come up with these theories and mathematical models that help solve certain problems of these financial systems or the economic system, right? So you would find physicists because they're crazy people. They can go anywhere, right? So the careers, the world is open. You can go anywhere. You can be an entrepreneur. Again, you will have skills to be explorative, so you can be a crafter. You can be an artist. You can do wonders if you want to pursue physics. So physics is nothing boring. It is nothing to be dealt with just in the form of a subject. You can say it's kind of an art. It's kind of a skill that if you learn, that will last with you forever, and that will help you in building any kind of career that you're trying to build, right? Whether as an engineer, as a doctor, or as just as a researcher. Physics is going to open up your mind, how nature works around you and how you can perform your task better, right? So something for the parents. For IGCSE physics at Roots Millennium Schools, we believe in parent-teacher meetings. We understand that the circle between the teacher, student, and the parent should be well knitted, so that the things are tracked, the things are well understood, and everything is well knitted for enhancing the performance of the student to be able to get good grades. If the student is falling falling behind in the class, then remedials could be planned, and everything is well open between the three peers of this three components of this circle, so that the child growth is monitored as well as well planned, so that once the exams are there, the child is able to perform both confidently and effectively, right? So for that, we have parent-teacher meetings, we have WhatsApp groups broadcast where you have coordinated calls, we have Microsoft Content Tracker for lessons, we have Microsoft Digital Notebooks, the past paper booklet tracking, that's, as I said, is also available by the Cambridge. So these are the things that will help the parent, the teacher, track the performance of the child, and the mutual collaboration will help nurture the child to have good grades. Thank you for your time. I hope things were clear to you. If any student or parent has any questions, please post it up in the comment section. I'll try to respond as soon as